All right, this is going to be a quick review of sequences. Sequences are kind of a lot, so like I said, quick review. First of all, there's two different types of sequences, if you recall. I'm going to divide my line in half. There are arithmetic sequences, and there are geometric sequences. I mean, there are also other types of sequences, things like the Fibonacci sequence that are neither arithmetic nor geometric, but that's not really what we focused on, so I'm not going to even really get at that. Like, I'm not going to mention them again. The idea behind arithmetic sequences is that they have a common difference, right? It's a number that you add or subtract. With the geometric is a common ratio, and that's a number that you multiply or divide by. Though, actually, I'm going to even erase that part because it shouldn't be the number that I mean, you could see it as division, but you're always going to want to write the common ratio as what you multiply by. And in fact, it's like how you actually want the common difference to be what you add, because if you're subtracting, it's just like adding a negative. So arithmetic's what you add, geometric is what you multiply by. With both of these, I'm going to we're also going to want to look at the first term to write our sequence, to write our rules, right? But let's go ahead and do some examples. So arithmetic could be something like, let's say 7, 10, 13, 16. So see, dot, dot, dot. Each time here, what we're looking at is the change between the terms. Here, as you can probably see, our common difference here is +3. And with geometric, let's do an example of geometric. Maybe we have something like this. This is geometric because it is multiplying. And if we take a look at the terms and how they are changing, right? This is going to be multiplying by 2. So the common ratio is just 2. A couple of other things. Let's go ahead and I need my eraser to be bigger. Let's do some other ones. You can write equations for things. So let's say that we have, oh wait, blue, then 1. All right, so let's say we have -4, -9, -14, right? We can write this equation. It'll be based off of 2 factors. The first one being just the first term, right? And the second one being that common difference, which here, the common difference is -5. So the difference is -5. So we can write our equation. We'd say, okay, we have the first term at -4 minus 5 times n minus 1. So that would be our equation. And there's a couple ways you can use this. If you want to find, for example, like the 10th term, all you would do is you would go ahead and you would say, okay, let's substitute in 10 for n. And then, so that would, so do your parentheses first. So 10 minus 1 is 9. 9 times 5 is 45. So we would get -49. That's the 10th term, -49. The other thing you can do is you can say, okay, when is it going to be -19, right? So let me go ahead and do that one as well. Let me erase this. So let's say, okay, so this is, so this one was the 10th term. is negative 49. I am getting a lot of emails. I don't know if you guys can hear that, but I can hear it, and it's kind of driving me nuts, so I will check those in a moment. So, and then the other thing you can do, like I said, is you can use your equation, you can set it equal to something else if you want to say, okay, I know that at some point we're going to get a value of negative 19, right? So if we have negative 19, we can set that equal to our equation, negative 4 minus 5n minus 1, and we would solve for n. And to solve for n here, we're just going to need to use our inverse operations. So let's go ahead and do so. What color have I not used yet? How about this strange color? So we'll go ahead and add 4 on both sides. This is 0. Oh my goodness, someone really wants to talk to me. That is fine. All right, and this is negative 15 is equal to negative 5 and minus 1. We'll go ahead and then divide both sides by negative 5. That cancels, and we are getting 3 is equal to n minus 1. Don't forget to add 1 on both sides. We get our final answer over here of n is equal to 4, right? Which means the fourth term is negative 19, which hopefully you could see, because see, it's just the next one in the sequence. So that is arithmetic. Let's go ahead and do a geometric example, pretty similar. Let's do a geometric where our sequence is being divided. So let's say we have 625, 25, 5. Maybe you're not sure what the relationship is here. So we can go ahead and take a look. So what I do here is I'm just checking on my calculator, double checking that I did this right. You can divide 620, you can actually go backwards. So what you would do to figure out what the ratio is look at like 25 divided by 625. And we're getting 1/5. Divide 5 by 25, and again we're getting 1/5. That's because moving forward, so going forward in this direction, means that we're going to be multiplying by 1. We're dividing by 5, but our ratio again is what we want, so we're multiplying by 1/5. Our first term is 625, so that would go first. Our ratio, if you remember, goes in parentheses, and it has an exponent of n minus 1, which makes a geometric ratio not a linear equation, but a exponential one. Again, we could do the same thing here. Let's say we wanted to let's say that we wanted to figure out what is the sixth term, right? That means we would just replace n with 6. So we would have our equation here, 625, 1/5, and then replace the n with 6. And then you're definitely going to want to use a calculator here. Do be careful when you're using your calculator. When you do the exponent, if you do not put the 6 minus 1 in parentheses, it is going to do it differently. What your calculator will do is this, which is totally different, not what we want. So make sure you either put it in parentheses, or when you put it in your calculator, just do an exponent of and then do that subtraction in your head. it's really easy. 6 minus 1 is 5. So you can just put that in your calculator. And what I'm getting here, now they give it to me as a decimal, but this is just going to be, wait, 0.2, which is 1/5. Is that right? Why does that not seem right? So let me double check. I'm going to do it again. I'm brainless. All right, so let's make sure I'm doing this correctly. 1 divided by 5, exponent. Oh, wow. I skipped a number. All right, this is fine as long as I change my sequence a little bit. That should be 125, and that should be 25. Now it's good. Totally brainless. Sorry, it's late. There we go. Now that's correct. Yay, all good. All right, but like I said, you can also do other problems. What if they wanted to say when, oops, what have they said? What term has a value of 1? Then that's that idea of the whole thing is going to be equal to 1. So like 1 would be equal to our equation. I know numbers. But what I would actually suggest here is that you use a calculator. So I'm going to use my calculator and be like, okay, 625 divided by 5, that's giving me 125 divided by 5 again. That's giving me 25 divided by 5 again. That's giving me 5 divided by 5 again. That's giving me 1. How many times did I divide by 5? I did it 1, 2, 3, 4 times. No. Did I do it 4 times? Yes, I did it 4 times. And 625 was my first term. So that's my first, then my second, third, fourth, fifth. So it would actually be n is equal to 5. There is a way to solve this algebraically, but it's using what's called logarithms, which you don't get into until math 2 or 3. 3, I think. I don't know. Not sure. Don't remember. But anyway, that is just a quick review of sequences. If you have questions, please ask.